Okay, here's the thing. Number 10, Uranus rotates sideways. Most planets spin upright, like disciplined dancers, aligned, predictable, stable. Uranus refused. It tipped over, 98 degrees, rolling through space, like a dropped coin. Seasons don't simply change, they flip. One pole faces the sun, for decades, then darkness, for decades more. Entire hemispheres freeze, then burn, then freeze again. Something hit it. Hard, possibly a planet-sized collision, a cosmic accident, violent, chaotic, but revealing. Planetary systems aren't gentle, they are unstable, fragile. One impact can rewrite everything. Orbits survive, but identities change. Uranus shouldn't look like this, yet it does, meaning collisions shape reality, more often than we thought. And if planets can be flipped, what else can be overturned? What we call normal may just be temporary. The solar system isn't orderly, it's lucky. And luck doesn't last forever. A single impact changed a world. The next discovery shows something stranger. A planet found before anyone saw it. Number 9. Neptune was predicted before seen. A planet appeared, first in mathematics, not in the sky. Astronomers noticed something wrong. Uranus wasn't moving correctly. Its orbit drifted, too fast, too slow, too strange. Gravity didn't match expectations. Something invisible was pulling it. No telescope could see it, yet two mathematicians, independently, calculated the disturbance. They mapped an unseen world, using equations alone. They predicted its position, where it must be, where it had to be. Observatories pointed their lenses exactly there, and Neptune appeared, right on schedule, a planet discovered by logic, before sight, before confirmation. Reality followed mathematics, not the other way around. That was new, dangerously new. It suggested something unsettling. The universe obeys structure, even when hidden. Patterns exist before observation, meaning reality is constrained, governed by deep rules, invisible rules. We didn't discover Neptune. We uncovered inevitability. Prediction became exploration. Equations became telescopes. And suddenly, math wasn't just describing the universe, it was revealing it. If unseen planets can be predicted, what else already exists? Waiting in equations, dark matter, dark energy, entire hidden worlds, possibly already implied. Reality may be larger than observation, far larger, and sometimes knowledge arrives before discovery. But Neptune still behaved normally. The next discovery didn't. It forced us to change the definition of a planet itself. Number 8. Pluto forced us to redefine planet. Pluto was once the 9th planet. Small, distant, mysterious, a lonely world. At the edge of the sun's reach, for decades, it felt complete. 9 planets, a perfect list, neat, comforting. Then telescopes improved, far beyond Pluto. More objects appeared, dozens, hundreds, thousands, icy worlds, orbiting in silence, some nearly Pluto's size, some larger. One discovery changed everything. Eris, a distant body, massive, comparable to Pluto. Suddenly, a question emerged. If Pluto is a planet, why not Eris? Why not the others? The list would grow endlessly, dozens of planets, hundreds of planets. The word would lose meaning, so astronomy made a decision. In 2006, Pluto was reclassified. Not a planet, a dwarf planet, a technical change, but emotionally, a shock, a reminder that science evolves. Even definitions aren't permanent. Categories shift. Reality doesn't care about labels. We create order. Nature breaks it. Pluto didn't change. We did. Our understanding did. The solar system became larger, messier, more complex. Planets weren't rare objects. They were part of a spectrum, a continuum, blurry boundaries, no clear edges, which means something deeper. Nature doesn't divide cleanly. Our categories are approximations, useful, but temporary. Pluto taught us humility. Even familiar things can be redefined. And if the meaning of planet can change, how many more assumptions are waiting to collapse? Because Pluto was only the beginning. The next discovery revealed something impossible. A planet around another sun. Number 7. The first exoplanet around a sun-like star. For most of history, planets meant our planets, Mercury, Venus, Earth, Mars, familiar, local, unique. We assumed planetary systems were rare, maybe even special. Then came 1995. A star named 51 Pegasi, ordinary, sun-like, stable. Astronomers detected a wobble, tiny, rhythmic. Something massive was pulling it. A planet, but not a normal one. 51 Pegasi b, a giant world, larger than Jupiter, orbiting extremely close to its star, closer than Mercury orbits the Sun. 1 year lasted only 4 days. 4 days. Gas giants weren't supposed to exist there. Too hot, too violent. Planet formation models predicted otherwise. Theory said no. Observation said yes. Hot Jupiters shattered assumptions. Planets could migrate, move inward, shift dramatically after formation. Solar systems were dynamic, chaotic, unstable. Our planetary architecture might not be typical. Thousands of exoplanets followed, every discovery stranger than the last. Tilted orbits, eccentric paths, scorching worlds, frozen giants. Planetary systems weren't orderly families. They were survival stories, meaning Earth's orbit may be unusually calm, unusually safe. We stopped asking, do other planets exist? We began asking, how strange can they get? And the answer kept getting stranger. Because the next discovery revealed something worse. Planets that should not exist at all. Number 6. Hot Jupiters shouldn't exist. Jupiter is massive, a gas giant, cold, distant, where physics said it should be, far from the sun, where ices form, where gas can accumulate. That was the rule. Then telescopes found giants, hugging their stars, closer than Mercury, orbiting in days, not years. Their atmospheres boil. Temperatures exceed 1,000 degrees, clouds of vaporized metals, iron rain, glass winds, entire worlds evaporating. These planets weren't anomalies. They were common, too common. Planet formation theory broke. Gas giants require distance, time, cold material, but hot Jupiters exist anyway, meaning planets move. After formation, massive worlds migrate inward. Gravitational chaos reshapes systems. Planets collide, scatter, fall. Some are swallowed by stars. Others survive impossible journeys. Our solar system avoided this fate. Barely. If Jupiter had migrated inward, Earth might never have formed, or survived. Our existence depends on orbital stability, a fragile balance, easily disrupted. Hot Jupiters reveal something unsettling. Planetary systems are violent places. Stability is rare. Luck again. Always luck. Our calm skies hide turbulent histories, invisible catastrophes. That already happened, or nearly did. Hot Jupiters shouldn't exist, but they do, which means planetary systems are less predictable than we imagined. And if giant planets can move freely, smaller worlds may not stay safe, including Earth-like ones. Because the next discovery showed something unexpected. Planets unlike anything in our solar system. Common. Everywhere. Number 5. Super-Earths are everywhere. Earth feels perfectly sized, not too large, not too small, just enough gravity, just enough atmosphere, just enough stability. It feels ideal, natural, typical. Then we searched other systems and found something missing. Earth-sized planets were rare. Instead, astronomers kept finding larger worlds. Super-Earths. Planets 2, 3, even 10 times Earth's mass. Rocky, dense, common, extremely common. Many orbit close to their stars, packed tightly together, entire systems filled with them. Our solar system has none, not one. Between Earth and Neptune, there is a gap, a strange absence, a missing category. Nature prefers super-Earths, but our system skipped them. Why? We still don't know. Some super-Earths may have thick atmospheres, crushing pressures, endless oceans, or continents under massive gravity, mountains flattened, volcanoes amplified, plate tectonics altered. Even the chemistry of life could change. Gravity shapes biology. Stronger gravity changes evolution, changes anatomy, changes survival, meaning life elsewhere may not resemble life here. Earth might be unusual, not because it is large, but because it is small. Small enough for balance, large enough for complexity. Super-Earths suggest planetary diversity is wider than expected. Nature experiments freely, different sizes, different environments, different possibilities. Our planet may not represent the average, it may represent an exception, which means something uncomfortable. Our definition of Earth-like may be biased, limited, incomplete, and the universe may prefer worlds very different from ours. But size isn't the only surprise. The next discovery revealed planets with no star at all. Number 4. Rogue planets drift through darkness. Planets are supposed to orbit stars, bound, anchored, gravitationally loyal. That was the assumption. Then astronomers found planets with no star at all, rogue planets, drifting alone through interstellar space, cold, dark, invisible, ejected from their birth systems, thrown out by gravitational chaos, planetary pinballs, scattered by massive collisions, or migrating giants. Some may outnumber stars, billions, possibly trillions, worlds without sunlight, without sunrise, without seasons, endless night, yet some may still have heat, residual warmth from formation, or radioactive decay deep inside. Subsurface oceans could remain liquid, hidden seas beneath frozen crusts, life in eternal darkness, energy from chemistry, not sunlight, meaning life might not require a star. Habitability expands dramatically. The galaxy becomes more crowded, more alive, more unpredictable. Planets are not permanently tied to suns. Orbits are temporary arrangements. Gravity reshuffles everything. Worlds are lost, frequently, meaning planetary systems are not stable homes. They are temporary gatherings, cosmic traffic patterns. Some planets stay, some leave, some wander forever. Our solar system likely lost worlds long ago. Forgotten planets, gone, which means something unsettling. We may only see survivors, not the full story, and somewhere in the dark, entire oceans may drift unseen, carrying chemistry, carrying possibility, without a star, without warning, without detection. Because the next discovery suggests many planets may not even have land. Number 3. Water worlds may dominate the galaxy. Earth feels balanced. Ocean, continent, sky. A delicate ratio. Water covers 70%, yet land shapes civilization. Climate stabilizes, chemistry cycles, life adapts. We assumed this balance was common, then exoplanet data suggested otherwise. Many planets may contain far more water, not oceans with continents, entire planets, covered completely, no land at all. Endless global seas, hundreds of kilometers deep, water compressed into exotic forms, ice that isn't cold, ice that forms under pressure, layers of supercritical fluid, no beaches, no mountains, no erosion cycles. Carbon cycles change, climate behaves differently, life evolves differently, or struggles to begin. Deep oceans separate atmosphere from rock. Essential chemistry may be blocked, nutrients trapped below crushing depths, energy pathways limited, or transformed. Water worlds could be stable, calm, quiet, biologically slow, or biologically impossible, meaning Earth's mix of land and ocean may be unusually fortunate. A narrow configuration, a narrow window, too little water, dry desert planets, too much water, ocean planets. Earth sits between extremes, balanced, rare, or simply temporary. Planet formation models suggest water delivery varies widely. Some worlds flood, others desiccate. Chance shapes habitability, not intention. Water worlds expand our imagination. Life might arise differently, or not at all, meaning habitable zones alone are insufficient. Temperature is only part of the equation. Geology matters, atmospheres matter, balance matters, and balance may be uncommon. Because even stable worlds may not remain stable. The next discovery revealed how violently planets are born. Number 2. Planet formation happens violently. We imagine planets forming gently, dust slowly gathering, pebbles becoming rocks, rocks becoming worlds, calm, orderly, gradual. Reality is harsher. Young planetary systems are chaotic, crowded, unstable. Protoplanets collide constantly, massive impacts. Planet-sized bodies crash together, melt surfaces, vaporize oceans, reset atmospheres. Earth itself survived such violence. A Mars-sized object struck the young Earth. The collision reshaped everything. Debris formed the moon, our closest companion. Born from destruction. For millions of years, Earth's surface was magma, molten oceans of rock, skies filled with vaporized minerals, nothing recognizable, nothing stable. Planet formation is not construction, it is survival. Most worlds do not remain intact. Some are shattered, some are ejected, some are consumed by stars. The calm solar system we see today is the aftermath, a graveyard of failed worlds, invisible casualties. Our moon stabilizes Earth's tilt, controls tides, influences climate cycles. Without that ancient impact, Earth's environment may be chaotic, extreme seasons, wild axial shifts, possibly hostile to complex life, meaning catastrophe-enabled stability, destruction created habitability, violence produced balance. Planetary systems are not designed, they are filtered. Only certain outcomes persist, only certain worlds endure, which means our existence depends on ancient disasters, perfectly timed, perfectly destructive. Without them, no familiar Earth, no familiar sky, no familiar story. Because the final discovery changes the question entirely, not how planets form, but whether our planet is special at all. Number 1. Earth may not be special. For centuries, we believed Earth was unique. Perfect distance, perfect mass, perfect chemistry, perfect conditions for life, a rare cosmic coincidence. Then the discoveries accumulated. Thousands of exoplanets, thousands more candidates, rocky worlds, temperate worlds, atmospheres detected, water signatures hinted, organic molecules observed, planet formation appears efficient, stars commonly host planets, often multiple, often complex systems, meaning planets like Earth may be common, not identical, but similar temperature ranges, similar sizes, similar compositions. Habitability may not be rare, it may be expected, statistical, inevitable. The Copernican principle returns. We are not central, not privileged, not uniquely placed, just one outcome, among many, meaning somewhere. Another world may orbit quietly, clouds forming, oceans moving, chemistry evolving, possibly life emerging, possibly intelligence observing the sky, asking the same questions, wondering the same things, believing they are alone. The more planets we discover, the less exceptional Earth appears, and yet we still have no confirmation of life elsewhere, only probability, only implication, only silence, which creates tension. If habitable worlds are common, where is everyone? Maybe life is fragile. Maybe intelligence is rare. Maybe civilizations are brief. Or maybe the universe is full of observers, separated by distance, by time, by limitation. Earth may not be special, but awareness might be, which makes this moment strangely important. A thinking species on a small planet around an ordinary star, trying to understand how ordinary it really is. We began with tilted worlds. We end with perspective. Planets are not static objects. They are experiments, collisions, migrations, transformations. The universe builds countless variations, most unfamiliar, some unstable, a few balanced. Somewhere among them exist conditions for awareness, for curiosity, for questions like these. Astronomy didn't just expand the sky, it expanded possibility, and the more planets we find, the more reality feels open, unfinished, still discovering itself.